My name is Ben Segal. I am a second-year PhD student, and we are at Stevens Institute of Technology in the Edwin A. Stevens building. And this is the Stevens Shock Tunnel. So a shock tunnel is an impulse facility that is used to simulate free flight conditions. And our shock tunnel is capable of going at Mach 6, which is 6 times the speed of sound. This lab is special because we do experimental simulations that can either prove or disprove computer simulations. So basically how a shock tunnel works is we have a primary diaphragm, secondary diaphragm loaded into the tunnel, and we fill up a driver section and a driven section with nitrogen or helium. And basically those diaphragms are what starts a tunnel. When you have the primary diaphragm in here, it has a burst pressure, and that burst pressure is going to induce the incident shock. And that incident shock is like a piston, which basically propels the gas from the driven section through the nozzle as the nozzle expands the flow to Mach 6 at a steady rate over the test article in the test section for about 4 to 6 milliseconds. The test article is just a model. They could be analogous to anything that is going at hypersonic flight at these altitudes. We have a new test article, which is a metal hollow cylinder flare. So it is a hollow cylinder with a flare attached to it, and it has 45 sensors along the body and the surface. So we can actually study the pressure gradients and understand what's happening during this flow, both the starting of the flow and the ending of the flow, which are the transient periods, as well as the steady state. Basically, what we want to do is simulate and analyze flow and Mach 6 over these articles. What this could tell us is if you have some sort of hypersonic vehicle flying at that speed with the same geometry, you could basically simulate the interactions. It's really about bringing the theoretical knowledge that you learn in classes to practical understanding. So for me, I love learning, and this is what I do on a daily basis. And especially being a mechanical engineer and going into my doctorate, I'm a very hands-on person. I need to see what I'm doing to be able to understand it. And to do what we're doing here is very much bringing fluid mechanics and any like aerospace class and aerodynamics into practical understanding. You get a lot out of it when you see that experiments work, as well as having a facility like this where you can just tell anybody, like, I work with stuff that's going 6 times the speed of sound. It's really cool. Yeah.